So why use Tdd? Programmers start by creating the test, and this allows them to focus on the interface and on the design. Only after thinking about the issue at hand will developers start coding the production code, and that would highly benefit the final implementation. Furthermore, Tdd puts regression testing into place easily, and this ensures a quick identification of recent changes that broke the code. By ensuring that all the previous tests still pass regression testing, when you add a new feature and corresponding test, you ensure that the new code did not harm the existing code. Tdd is a technique that is easy to learn, as you can see by the previous example that was given, but it takes a lifetime to master. Speed is crucial in Tdd. For one hand, each programmer will be able to fine-tune on his technique, and while this might take some time to complete, tests in Tdd should occur rather fast, 1 or 2 times every minute. If speed is not maintained, tests will not be run often, and the micro increments of proof that are the basis of Tdd will not work as expected. This practice leads us to the levels of testing in the development arena. Automated tests are mostly connected to the programmers and can be unit tests, integration tests, or end-to-end tests. While unit tests run in hundreds per second, integration tests are in a handful per second, and end-to-end tests occur in seconds per test. A relevant aspect in automated tests, as it was previously presented in the continuous testing module, is the fact that most tests should be unit tests. Only a small fraction should be integration tests, and only a handful should be end-to-end. All things considered, Tdd can be used at each level. Let us see for each level approaches to conduct them successfully. Unit tests should run fast, and they are the first and direct approach to introduce Tdd. Let's define what a unit test is and what it is not. A test is not a unit test if it talks to a database, or it communicates across a network, or it touches the file system, or you must do some special things to your environment, such as editing configuration files, to run it. If a test does this, this is called an integration test. So creating unit tests requires good design, and that takes practice. Highly coupled systems are hard and difficult to test. So like a big bowl of mud or spaghetti code and software, it makes extremely hard and difficult to write small, unit, and dedicated and specific tests. This implies that we should look for ways to decouple our code. And this also takes practice. A hint is to try to separate each class or set of related classes that can be tested in isolation. Make your design simple. Simplicity is key in unit testing. Each integration test should test just one interaction with the outside world. These focused integration tests set up external dependencies, prepare the environment for the tests, and ensure that the previous environment is restored afterwards. Tests should run exactly in the same way, regardless of the order they are run or the state of the machine. You shouldn't need many integration tests. It's a sign or a design issue. Consider the following. If you need a lot of integration tests, it's a sign of design problems. It may mean that the code that talks to the outside world isn't cohesive. For example, if all your business objects talk directly to a database, you'll need integration tests for each one of them. A better design would be to have just one class that talks to the database. Then, the business objects would talk to that class. In this scenario, only the database class would need integration tests. The business objects could use ordinary unit tests. Another proper implementation might be to use an ORM object relational mapping to interact with the database. Regarding end-to-end tests, this allow you to execute large paths and several aspects of your features and your system as a whole. Examples include acceptance and functional tests. These tests are costly since they involve a lot of work and setup. They are usually slow, and the good alternative is to use exploratory testing. On a side note, don't use exploratory testing to find bugs. Use it to determine if your unit tests and integration tests mesh properly. When you find an issue, improve your TDD strategy. So, when should we consider using TDD? It depends on what you want to test, and the suggestion is that you should test everything that can possibly break. Specifically for object-oriented programming, and for instance, private methods, a dedicated approach should be followed, and you could start with public methods and then refactor, and ultimately you will keep the tests that follow along the private ones already under test. What happens when you want to test a user interface? Well, there are specific tools that can be used to test a user interaction directly, and you should choose one. And does anyone refactor test code? Well, yes. And if it's not the case, everybody should do it. This code. It should be refactored. Some studies and surveys present some successful results, namely, TDD increases your confidence in your codebase and also improves the design of the interface. It works as a living documentation of the code, reduces the time spent on debugging, and makes the discovery of mistakes a fast process, where the developer is able to fix them